In this episode,
and he persuaded me to be his lab rat.
We're putting another one in 2 weeks' time.
There's no payback period. Your payback period is 0 days.
It takes into account weather forecasts, the electricity tariffs, the heat pump efficiency, and so on.
I don't know if it's interesting or not, but it's interesting to me.
Ping, ping, it's this radiator. Ping, ping, it's this radiator.
Easy for people, comfortable for people, no worries for people.
Soon is the answer to that.
We like to try before we buy.
hello and welcome to Homeowners Q&A. I'm your host Mars, and today we're diving into the relationship between heat pumps and smart technology. Joining me today are four incredible guests. We've got Emma Bohan from IMS Heat Pumps, Henri Castelyn from Havenwise, Luke Hodgkinson from Adia, and David Strahan, a passionate homeowner, heat pump champion, and journalist. Welcome, everybody. But before we get stuck into today's episode, we'd like to say a huge thank you to IMS Heat Pumps for sponsoring this episode. Established in 1997, IMS Heat Pumps is a trusted trader with offices in Perth and Sheffield. They specialize in the design, installation, and maintenance of ground and air source heat pumps, offering bespoke renewable heating solutions tailored to each property. With over 200 years of combined experience and certification from MCS, NAPIT, and HeatGeek, their skilled engineers ensure high-quality installations across Scotland, the North, and the Midlands. Right, guys, so let's start with Luke. Let's start at the beginning. So in terms of Adia, could you just tell us what Adia is and what the product offering is?
Adia is a smart control system for heat pumps, but different to some of the other ones, it's one that's installed with a heat pump up front. And we do have a hardware component, which enables a heat pump to be installed very simply in just 2 or 3 days, and crucially without major changes to pipework and radiators up front. Once after AD is installed, we then optimize the system to get the best performance out of your existing radiators, and then can provide recommendations after we've heated it for a month or two to tell you which radiators are bottlenecking your system. And this kind of allows you to shorten that upfront installation process and only make those changes when you're ready.
So walk us through the actual kit. So somebody's got an existing central heating system, call it a gas boiler. They want to switch to a heat pump and they want to potentially go with Adia. So what is the full kind of kit offering that actually they've got to get? And what is the process for that actual transformation?
We work with installers for Adia. So we're not a heat pump provider. Adia is compatible with a number of leading brands of heat pumps. And what you'll need is a heat pump, an Adia system, which involves a hub, which will go where your boiler used to go. This hub then plumbs directly into the heat pump and then into your existing central heating system. And that is the extent of the plumbing that needs to be done. So it's a really quick installation process. We then put we call them flow balancing valves. You've probably seen smart radiator valves that go on each radiator, and they allow us to modulate the output to balance the system and keep the home very comfortable whilst getting as much efficiency as possible. We do put temperature sensors in all the rooms as well, which just helps us to get a better picture of comfort. And yeah, so all of this is then used to analyze the room by room heat loss of the house, which we can use for those upgrade recommendations afterwards.
So these flow regulators, they are controlling the amount of water coming into that radiator. So it's actually saying that this radiator has to get to a certain temperature. And once it's got that, it just completely maybe shuts the valve down to prevent any hot water coming in. So that actually circulates that heat more around the property.
So not quite. So what's really important with heat pumps is maintaining system volume. So we avoid fully closing radiator valves whenever possible. It's very rare that we would fully close one unless a homeowner had said they really don't want that room heated at all. What we do is we use our machine learning to predict the flow that's going through each radiator, it's a non-trivial calculation. It's quite a complex thing to figure out. And then we move the valves into specific positions to essentially just modulate that output of the radiator. So we are maintaining those positions for hours at a time, but we will change the set points throughout the day, and it is responsive to something like an external heat source. Like if you put a fire on, we will recognize that and we will then close off that radiator to minimize the flow to that room. Likewise, if a shower window is opened, we'll then drive more heat to that room to level things out.
That's actually a good point. I'm sorry that I'm asking you all the questions at the outset, but You mentioned that the bathroom. So do the towel rails also get the little flow regulators on them?
We do put that on the towel rails at the moment. The reason for that is that the way that we calculate the flow rate that's going through each radiator is through a number of experiments which require us to have control over every single emitter. We are still in a relatively early stage, but I think we'll probably maintain that because controlling the towel rail can have a big impact on the overall efficiency of the home.
So Emma, you've been trialing Adia. Can you just tell us about your experience and what you've thought of it?
So my house, when I moved in 2018, brand new gas boiler. Even though we are heat pump purists, even I wouldn't advocate taking something with all that embodied carbon in off the wall just for climate's sake. So here I am though, 6 years down the line, and it was time for the gas boiler to go. Thought it had done enough. So off we go with the heat pump, and I'd met Luke, installer, I think, last year, and was, super interested. So in the world of design, radiator and emitter design and heat pump design, in my house, which is a collection of K1s and P pluses, the emitter schedule showed that every single radiator would need upgrading, sometimes significantly. From small K1s to enormous K3s, some rooms with additional K3 radiators in it. Apart from the upheaval of that, I'm thinking, finger in the air, you're talking 10 grand's worth of additional costs on top of the system. Oh, and by the way, on that emitter schedule, it says that in the old star rating from RHI, we would always try and get a 4 or 5 star system. My system had no stars. Some rooms were off the chart, and other rooms show that I'll only get any heat out of it if I'm running that system at 60 plus. So here we go. Let's stick a nadir on it and see what happens. Well, what happens is that went in at the end of October, so peak heating season, and we have been warm. Lo and behold, yes, teething problems. We all know it's still early stage, and I was all up for that. As a company, we do like to try before we buy, and we do that with anything really that we put on our consumer menu of choice. And interestingly, just discussing how cold it's been up north in January, periods of -5, -7, -2, and my house has maintained temperatures between 19 and 22 degrees throughout that period. So it can be done on tiny radiators. It was installed by 2 guys in 2 days, and we used an integrated Samsung EHS for that with a pre-plumbed cylinder. So again, all about reducing the amount of external components needed to be installed in a home. And on that basis, so far it's a winner. Now we are getting into the second phase of the data analysis, which is which, if any of those radiators, I should upgrade in order to start bringing the flow temperature down, because currently I think we're running about 52, 54, something like that. Now, if you think there are some companies out there that design as 50 as standard, that's not far off that, standard that, other people might think is very inefficient. I personally want to see that come right down. Luke knows I do, because that's not what we would expect for our homeowners. And so at the moment, I've just placed an order for 4 radiators. 4 radiators that are not K3s, that are replacing the footprint of the radiator that I've got, but are just bigger. So I've got a 600 by 600 P plus that's going to be a K2. I've got a 600 by 1200 K1 that's going to be a K2. And I've got 2 vertical radiators that are going from 4 panels to 6 panels. We then go back, we balance it again, we come back to the flow temperature, we should see that drop. The benefits, therefore, are I'm still 10 grand in my bank, not in my installer's company's pocket, which is great. But also, in October, as well as having, my cellar camped in for a couple of days and all this kit coming in and out of the house, I haven't had any disruption. I've had no floorboards up. I've had no radiators, no pipework changed. And, if you get into what the additional benefits are, is if and when we start getting the economics of, even if I ran it at 54 and did nothing, how many years am I going to be paying those higher bills before I get to, I should have upgraded my radiators? Is that 2 years, 3 years, 4 years? Will we see a change in the electricity price by then? So there's, lots of things there to unpack in terms of, distressed purchases, but also people who don't want to dive into that, massive realms of upheaval, who might want to think, the boiler is about to fall off the wall. So let's look at it now. Oh my gosh, that sounds like a massive project. And it sounds like another 5 or 7 grand on top of, your standard heat pump install cost. Things that I've not done yet. I have not switched to a heat pump tariff. And I believe that when I do, which is on my list of things to do, the never-ending list, then some of those running optimizations that Adia can do will align with those tariff time of use tariffs, or I mean, even if I switch to a supplier that provided a bog standard 15p or whatever it is across it all, then I'm only going to see another benefit, which then when you go into the economics of the cost benefit return on investment analysis, do I get it 7 years before I should have upgraded all my radiators?
Planning to install an air source heat pump? Then get your copy of Bodge Buster. It's packed with must-ask questions, real homeowner insights, and a practical guide for a smoother installation. Available in print and on Kindle. Link in the description. Brilliant, Henri. Let's change gears. So your product is quite different to Adia's. So could you just give us a rundown of what Havenwise is and how Havenwise operates?
Yes, absolutely, Mars. So at Havenwise, our goal really is to make people with a heat pump comfortable with the lowest possible electricity bills. The way we do that is we give people a very easy to use app where they set their comfort requirements. So for heating and hot water. In the background, our algorithms then fully control the heat pump in the most optimal way. It takes into account weather forecasts, the electricity tariffs, the heat pump efficiency, and so on. And all to make sure that it is super easy for the homeowner to control their heat pump. It is as comfortable as possible, and it is with the lowest possible electricity bills due to all of that optimization. For the installers, our goal is to really save them time after installation. And so we do that by having a portal for them where they can track the performance of their heat pumps that they have installed. And also by reducing the need to manually tweak the settings of the heat pump and or to go back to that property to do so and answer questions from homeowners. So that's really what we do. One of the nice things of the Havenwise approach is that we don't need extra hardware. So all of that we do through the internet connection of the heat pump.
So how does that integrate into the actual heat pump? So are there specific brands that you can only work with? How does that integration actually take place?
So we integrate directly with the manufacturer of the heat pump. And then when the heat pump is internet connected, we just directly talk to and read from the heat pump through its internet connectivity. That's how it works. In terms of brands, we are compatible with a good number of big manufacturers and continuing to build that list. It's a matter of doing the work rather than any limitations per se from a technical perspective.
So David, you've been using Havenwise for a while now. Could you just give us a rundown of your system, how that actual integration worked, and how it's actually performing for your system?
The short version is performing very well now. The house is, I've been a 3-bedroom terraced house, and the house is toasty warm, and I'm saving quite a lot of money versus a gas boiler, around about 25 to 30%, depending on how you calculate it. How can I put it? It wasn't ever thus. I installed my heat pump about 3 years ago. And it's fair to say I've been on a bit of a journey. I've made all the mistakes that most people make, or rather, perhaps I should say that most installers make to start with. And it took a while to sort all that out, towards the tail end of which Henri and Havenwise came in and basically got the system running as well as it is today. It's a Mitsubishi EcoDan, and it was installed, as I say, about 3 years ago. I like the installers; they seem to do a really good job physically, but I think, as the data suggests, most people have this experience. The commissioning fell down a bit. I quite early in the process asked the installers, "Oh, can I keep using my thermostatic radiator valves?" And they said, "I know I have about a half a dozen, or did have." And they said, "Yeah, sure, we can make those. We can make all those talk to the system. That's fine." Which was very obliging, but actually what they should have said is, "Yes, we can, David, but you'd be mad to run it that way because it'll be really inefficient." So that was one thing I think that went wrong. And the next was that at the end of the job, Friday night, fitter wants to get home. David, would you like us to set up a weather compensation? And I didn't, in my ignorance, I said no. I didn't really know anything about it, and just leave it at 50. I'm sure that'll be fine. So for the first 2 years, the system ran fine, but it was probably costing me 150 quid more than gas per year. And I got a bit sick of this, so started to play around found out about and started to play around with the weather compensation curve myself. Straight away, raised the SCOP the COP from less than 2.5, probably 2 to 2.5 to 3. So that was fine, but that's where it was sitting, and that's not even still. That's still costing a bit more on gas. Somehow I ran into Henri online, and he persuaded me to be his lab rat. And so that's what happened, and basically Havenwise took control of the heat pump, started running it as Henri has described, and that's raised the SCOP to 3.5. And again, that's really only even Stevens with gas. That's about a very small saving, 5 or 6%, something like that. But then on top of that, you've got the effect of the agile tariff and the financial optimization and weather optimization that Havenwise provide. And that's taken the savings, as I say, to 25 to 30%, depending on how you calculate it. So at the end of this year, at the end of March, I'll have a full year of that data. And it looks to me like from my own kind of amateur back of the envelope calculations, that even if February and March are as cold as January, and even if the agile prices are as miserable as they've been recently, my total energy bill will be about 1,300 quid for the year, compared to the off-gem cap of about 1,700 quid. So again, it's 25 to 30% savings, depending on how you look at it, which I think is fantastic, and is quite, it's totally opposite to the kind of general narrative that you get about heat pumps. The interesting thing I will say is that this I don't know if it's interesting or not, but it's interesting to me. Probably the SCOP now at 3.5 is in fact what the installers predicted. That was in their calculation to start with. So I think the system's running physically as efficiently as it can. That in itself would only be even Stevens with gas. On top of that, the bulk of the savings have basically come from optimization, not from the efficiency of the system. Now, obviously, if it were a SCOP of 4 or higher, then you'd have a higher baseline, and there would be higher savings just from efficiency. But what that says is that optimization is really, really important. And when I write about these things and get commissioned to write about them, my argument is that we should basically make optimization mandatory, because essentially that there is so much saving to come from that. As far as the consumer is concerned, who cares where the savings come from? Engineers may care about doing a great job, or some of them may not. What this does is take that out and take the commissioning particularly out of engineers' hands, and puts it in the hands of AI, and it seems to do a pretty good job.
Just from a setups perspective, David, how easy was it to do? I assume you did the whole thing yourself. So could you just walk us through that process? Was it minutes? Was it hours? Was it days? How long did it actually take for you to set the whole thing up?
It was dead easy because it's virtual. I mean, I had considered a couple of other optimizers, but they need little boxes of tricks to be wired directly into the heat pump, and that, obviously you've got to get a guy out to do that. This is actually, it's a few numbers in there, and the thing's set up. So it's dead easy. That, I think, is that's a real advantage. To start with, there seemed to be some argument about whether the manufacturer's API, application programming interface, I think, is reliable enough for a virtual optimizer really to be, as it were, secure and reliable itself. But that doesn't seem to have been a problem. I mean, all the big manufacturer suppliers like Octopus and Aera are doing this anyway. It kind of all comes preloaded, as it were. So I don't think the other manufacturers are going to get away without making sure that their APIs are reliable, because they're just going to get left behind if they do. So I think that issue is kind of, I don't know, probably in the process of being sorted. So yeah, no, I found it very easy.
So Luke, David mentioned commissioning, and this is something where the bulk of poorly installed systems fall down. It's basically the lack of commissioning. So does Adia go to some extent actually rectifying poor commissioning? Can it actually rectify some of those initial faults if somebody has installed that system poorly?
Firstly, I think it's important to mention that Adia will set the weather compensation curve and will balance the system of the home, which is fundamentally the two important parts of commissioning that can lead to poor system performance. And we automate that process. We do that with an app. So the installer or the homeowner can set what temperature they want each room to be in the house. And those can vary. So if you want your bedroom a bit cooler than your living room, or if there's a room that you're not occupying most of the year, you can deprioritize those rooms. That's really it. So there's no typing in a weather compensation curve into the controller, none of the complicated hot water setup. You just put your settings into the app and it's up and running. So it really does simplify and de-risk that commissioning process as well. The other important thing to say is that because we're doing this and because we're shortening the installation process so drastically, I think really relevant to what David's saying, there's another way of looking at this, which is if you can bring down the cost of installation by shortening it so much, then we don't have to think about payback periods of energy bills, right? With Adia, we're not far away, and I mean Emma can correct me on this if she thinks so, but of actually having a heat pump installed for the same price as a gas boiler. And for that reason, if your heat pump's installed for the same price as the gas boiler, there's no payback period. Your payback period is 0 days. As long as we're achieving that parity, that SCOP of 3.5, it's essentially a net neutral change for the homeowner, but with all the benefits of a better technology and of lower carbon footprint. Then we layer on these smart tariff tracking abilities, and suddenly you're saving money by changing that installation process itself. We can really change the financial decision making for the homeowner.
So you mentioned that you're in pilot stage. When is Adia going to be kind of fully ready in the UK?
Our aim is to continue to expand the pilots throughout this winter. We want to so we are open to piloting with a couple more installers. We have a little bit more capacity. It'll be next heating season that we will be commercially launching.
And we're putting another one in 2 weeks' time.
Where's that going?
My sister's house. As I say, we like to try before we buy. There's every member of staff is at risk of having, a new, unique solution. So, every member of the senior team has trialed something, whether it's a new to us product and that we're going to put out to our clients. We want to make sure that we are only selling stuff that we know, that we, test and install and that it works. So, yeah.
I have a question for Luke. Is there a danger that somebody is miserably cold after one of your installations? Could it be the case that the radiators are so inadequate that your system can't cope with it? Or are you discovering, or do you think you're going to discover actually that this whole business about radiator sizes is kind of irrelevant?
I wouldn't say it's irrelevant. I think there's been a really enabling technology and some more research into this area that says that at this time it's very unlikely that's going to happen for the majority of homes. The reason for that is that R290 heat pumps, so modern heat pumps, natural refrigerant, far better for the environment than R32 and can perform well at higher flow temperatures. So the one that we have installed at Emma's house can go up to 70 degrees, 75 degrees, I think, for hot water. It shouldn't be used at that for extended periods of time. And as we said, in Emma's house, we're maxing out at 52, 54, but they're very comfortable at those temperatures. And according to a recent study from Nesta, that came out last year, the vast majority of homes, I think they said it was over 90% of homes in the UK, can be heated with flow temperatures of 60 degrees or less. What's important as well to run with a heat pump is that because it has a lower delta temperature, the mean water temp going through your radiators at higher flow rates are going to bring down the required flow temperature compared to what a boiler would be doing. Every home that we've gone into, we've been able to keep warm. And that's been with flow temperatures below 60 degrees in all of those homes.
So Henri, David actually mentioned that he was able to get his SCOP up from 3 to 3.5 after he put Havenwise in. What happens in the background with your software or algorithms that are actually able to tweak these machines to extract this additional kind of efficiency out of these heat pump units?
Many different things in parallel. What our algorithms do is they learn about the building to start with. So they figure out how fast does the building heat up, how fast does it cool down, how much heat can it retain, all these things based on outside temperature, flow temperature, etc., all that. So we know exactly how the building reacts to a bunch of different parameters. And then from there, we combine that with how heat pumps operate. So we know the efficiency of a heat pump. We combine that with the tariff of David. So David is on optimises, which changes every half hour. And all of that goes into the models. And then our models know exactly how to run the heat pump to ensure the minimum possible electricity cost for David. And I say cost rather than SCOP, because for the end user, it is always about cost. They don't care about SCOP. So sometimes we do trade off a lower SCOP for a lower cost. Meaning if, for instance, if Agile goes very low in price for a moment, we will run the heat pump a bit harder. During that period, the SCOP will get a bit lower. But if you can run your heat pump at a third of the price now versus later, it is totally worth making that trade-off. So all of that goes into the models, and then we know exactly how to run the heat pump to make sure that the comfort requirements of David are set while minimizing the electricity bill for David. So that's how it works.
So Emma, you mentioned you guys are going to be putting in some new rads in your property. I think it was 4 in total, and you mentioned that they were going to have to be balanced. I would assume that that's going to be what Adia, what the actual system will do.
Yeah, so at the moment, every single radiator in the house, including the tower rails, has got one of these smart TRVs on it and a little sensor in the room that talks to the whole system. So when the new rads are on, those sensors will just be changed from one old rad to one new rad, and off it'll go again. And so it'll then start to recognize it's got a bigger volume to play with, and the system will go off and start balancing that, as we discussed, at a lower flow rate. The data that Luke produced and showed me literally says, if here's your flow rate, and if we want to reduce it down, I'm going to ping, it's this radiator, ping, it's this radiator. And some of that report refining that the Adia team are doing is going to literally give you that economic cost benefit ROI. So I've seen a kind of beta version of that says, here's an estimated cost of you upgrading these radiators. This is the estimated savings that it would bring because we can lower your flow rate. So I just think that's just such an interesting proposition, not just to be able to almost guarantee that I'm going to keep you warm throughout that house by you not doing anything now, so that you could, we do have clients, I can't afford to upgrade all the radiators, so they'll pick the main ones off the emitter schedule, and they'll do that with a view that they're going to do the rest and when they can afford it. But to be able to make those decisions based on actual data, given that you have maintained, a relatively comfortable house while that data was gathered, I just think is brilliant. It means that the additional cost, that additional upheaval can be managed over a time frame that works with a homeowner, as opposed to, having a team arrive and, shuffle about your house for 5 days or longer, doing everything all at once. You can say, right, I'll do 2 radiators in the summer because, I'll save the money up for it, or I'm going on holiday and that's the perfect time to do that bit of work. It gives a homeowner a lot more options that enables them to get involved now and pick up the stuff later.
So Luke, obviously we've been speaking about radiators. What happens to people that have got a mix of radiators and underfloor heating? Will Adia still be able to work?
Soon is the answer to that. There's no reason that Adia can't work with underfloor heating right now if you have the same temperature water going through you, if you're not doing any mixing. If you do have mixing, there's obviously an element of intelligence and hardware that needs to be added there, which is an ability to smart mix the temperature of your underfloor heating loops. And that's something that we will be working on very soon. Hopefully, probably piloting the next heating season is my expectation. So we are RADs only for now. We'll be launching a RADs only product commercially by the end of the year. But for underfloor heating, if there's people that want to pilot that in the next heating season, let us know, because we should have something ready to pilot.
Yeah, and I think it's fair to say, Luke, that if there's anybody out there who was really caught by the idea and wants to be part of this phase of the pilot, put your hands up, get in touch.
Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description. So David, you've obviously been messing around with the Havenwise app for quite some time now. Does it give you the ability to actually tweak things to kind of override the algorithm? So, if Henri's system is forcefully pushing a certain, direction for your heat pump and you don't want that to happen, can you override certain elements?
It's I mean, I'm not sure actually, Henri, if I've got the latest version of the app, but it's admirably simple. I mean, that's one of the things I like about it. It's not complicated, and yeah, you can boost and you can change settings and you can change the setback overnight and that sort of thing. Basically, what you do, all you do is say what I would like to happen in the house. What are the conditions that I want in the house when. You can boost the hot water, or you can, if you need to, or you can, any of those sort of normal things. Other than that, you don't fiddle really. I mean, that's the kind of lesson I learned, that kind of fiddling with this stuff. Well, actually, it's how I got to a better place with the operation of the heat pump. But the whole point of these systems, I think, is that most people, you probably, I consider myself a bit of a geek in this area, but I'm sure you all, in fact, you do all out geek me. But most people don't care about this stuff. It's got to be super simple. And all they really want to know is what it's going to cost, and is it easy? Can I have what I want in the home, and what's it going to cost? That's really it. And so I think that the simplicity of the app is a good thing. It's just basically let somebody else worry about all that complicated stuff.
For transparency, IMS have also been working with Henri, and we've been trialing a number of our own clients on the Havenwise system, and all have said exactly the same. Easy to use, easy to set up, and the optimization. It's fire and forget, which it's what we have with the gas boiler system. The white box on the wall. Once you put your program in it, you just leave it alone, don't you? And homeowners just don't care. We have a very interested section of heat geek types, open energy monitoring and SCOP chasing, and all of those weird and wonderful things. But at the end of the day, Mr. and Mrs. Miggins sat on the sofa really don't care as long as the bills are lower. And so the Havenwise application is something that we will be offering to all of our existing clients if they wanted to get on board. We're just working with Henri in all of those comms and the like.
The whole idea is exactly how David and Emma explained it, is to have a simple interface. You just need to think about, what temperature do I want? When do I need hot water? That's it. And so there's no need to fiddle with it. And because it's so simple, people can, boost hot water, or they can adjust their schedules as they want. But what we see is that once people set it, they forget about it. And it just runs in the background and Havenwise does all the optimization. For the homeowner, eventually the result really is, it's comfortable, it's super easy, and it means that it's guaranteed the lowest possible bills that you can get with that system. And like in David's case, he mentioned 30% saving against the gas boiler. I think if you look at your bills, David, and we also cross-reference that with our data, that's about £400 saving a year roughly for David, with zero effort really. So that's really what we want to get to, is we want to get to a place where it's easy for people, comfortable for people, no worries for people, and lowest possible bills, so that a heat pump becomes super, super attractive and a no-brainer.
It's terrible news really, because I'm going to have to find another hobby now.
Yeah, for sure.
The one thing that I love about these podcasts is everybody cites kind of issues with heating systems, and we're just the poster child for just about every single drama, because our system was just so horribly installed 6 years ago. We had always complained about our TV room getting really, really cold, and the installers would keep coming back, and they're just, we need to, crank up the one of the circulation pipes. There was never any thoughts as to how we can potentially increase the temperature in that room. Eventually, we upgraded the rad to a K3, which did help. That distribution circuit is something that's been so poorly lacking, because what we term the index circuit, our TV room, your system almost seems to be able to have the ability to basically rebalance everything. So the radiator that's sitting directly above me in the bedroom above me gets so hot, where the radiator in the TV room is lukewarm?
So balancing is a dark art, and I think most plumbers and installers will say this. Everyone has a different definition of how you actually balance a home, and that's because flow is non-linear. It's not predictable. If you close a valve in one room, it will force more flow through other radiators, but it won't do that linearly. It will depend where they are, which loop they're in a parallelized system. Our system is predicting that and learning your radiators, which means that we will find the right valve position. For those rooms that are easy to heat, we will restrict the flow a bit if we need to push more flow through the rooms that are harder to heat. And that means that in a system like yours, we would, if your bedroom's getting too hot, or if we know that we can prioritize a bit of that flow towards the room that's struggling to heat the most, and that's exactly what we'll do.
So do you have to drain the system in order to install your system? Or is it just a matter of removing the TRVs or whatever there's at the moment and putting these flow regulators on, and then obviously piping up the rest of it?
So the flow regulators just go on the existing TRV valve bodies on the radiators. So you don't need to cut pipes at any of your radiators. You can essentially, all the rooms just stay as they are. Obviously, Adia's hub is plumbed in between the heat pump and the existing central heating system. So that does require draining down the system when you install the heat pump, as you already would do.
Henri, your system's commercially available now?
Yeah.
What is the roadmap kind of going forward for the next 12 months into the next heating season? Are you guys going to be introducing any new features? Anything exciting in the pipeline?
There are quite a few things we're working on. So where to start? So there's additional compatibility with heat pump brands. So we're adding new heat pump brands to our compatibility list. We are bringing out a new version of our Homeowner app. So David is indeed on the previous version, and we're building the new version. And then there's quite a few cool additional things that we're working on, but I do want to keep them under wraps as we're building them. But yeah, like lots of new cool things to happen with Havenwise in the next 12 months. But in the short term, it's about new heat pump brands, new version of the phone app, and then we're also gonna do in the short term a revamp of the web portal for the installers, so it becomes even easier to track performance of their installations and spot any issues and solve any issues remotely.
Same question to you, Luke. So, you have mentioned that you guys are going to be introducing underfloor heating potentially and other things. Is there anything else that's kind of exciting that you guys are going to try and integrate over the course of the next 12 months before you go live?
The first thing is obviously just making sure that we have a fully commercial ready hardware platform, and I think we are very close to that, and that'll be ready by the summer. One of the really exciting things about Adia is our ability to measure room by room heat loss. We build up a digital twin of your home, and we can use that to make the recommendations that we've made for Emma. And so we are going to be essentially making that commercially ready as well. At the moment, what we've shared with Emma is a beta version. What we'll have by the next winter is something which is really robust and can pinpoint bottlenecking radiators and give you really detailed recommendations for what if any changes you should make, and the impact of those on your bills. So that's our main focus. I think another exciting project we are looking at is how we can reuse existing cylinders in homes when they're there. So there's a lot of waste in replacing perfectly good cylinders with heat pump cylinders because they have larger coils, and there are some pretty simple smart solutions that you can use to reuse existing cylinders and to use smaller cylinders if you don't have a lot of space in your home. We see this as another really important barrier for homeowners' mass adoptions of heat pumps. Most people have gone from having a boiler with a cylinder in their home to having a combi boiler, and they've reclaimed that space that the cylinder had. And now if you're asking them to go back to having a heat pump with a cylinder, then you're asking them to take over that space again in their house. So minimizing that space is really important. And we've already done an experiment with Vito in the south, where you can see we've used an 80-litre cylinder, or it's a 100-litre cylinder for a family of 4, which would not be okay without smart controls. And that's exactly what we've kind of been piloting there. So that's something we're investing some R&D into. It's something that we want to be providing for the next heating season as well.
So Emma, I'm going to put you on the spot. Last question to you. Obviously, you guys are working with Havenwise and Adia. As an installer, if you go into a property, which solution do you propose to homeowners?
So obviously we have a lot of clients out there at the moment, at which point we're a bit late for the Adia product. Havenwise is all for you. My recommendation will be to our clients that, if you've got a model that Henri currently supports, get yourself optimized with your time of use tariffs. It will only be good for you. In terms of our particular business, so 30% of our business is retrofit. So there's an argument that 30% of those people, you can save money today by not installing radiators, and we can install this bit of kit instead, and then you can monitor that and we can come back to you at a later stage. Self-build, new builds, this is something where they're ripping the pipework out anyway or starting from scratch, so not necessarily the choice for them. But yes, as those retrofit projects of ours build, it is definitely going to be something that we can offer. Some clients want to do the whole thing. Maybe they've decided that those radiators that have been painted 19 times and been on the wall since the 70s are going to come off anyway. But, there are a lot of clients who are budget conscious, and, there is that additional cost element that makes it, can we do it? Should we do it? It was interesting to see the Channel 5 project with the family. It was a large cost, and they'd holidayed at home rather than going abroad to save for that money. Some people just don't have the money to do the whole project as much as that they would. Innovative finance is another thing that we're seeing coming out of the market. But right now, this is a solution for you to get your heat pump now and think about the rest tomorrow, which I just think is a win-win, really.
I think what I hear from Emma is whatever is best for the customer.
Well, that's exactly how IMS works, Henri. We are not a one-size-fits-all. We are taking our customers' requirements into account. That's why we're not tied to any specific manufacturer. But we do try before we buy, and it's all about where the customer is, what budget that they've got, and what it is that they're trying to achieve for their property.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. So that's all that we have time for today, and a huge thank you to our guests Emma, Henri, Luke and David for sharing their expertise and insights. It's clear that smart home technology is transforming the way that we use heat pumps, making them more efficient, user-friendly and cost-effective. If you're a homeowner considering a heat pump or looking to optimize your existing system, I hope that this episode has given you plenty to think about. And before we go, I'd like to extend a big thank you to our sponsor, IMS Heat Pumps, for supporting this episode and for helping us to educate homeowners about sustainable heating solutions. Thanks for listening, and if you enjoyed this episode, please subscribe, leave us a comment, and give us a thumbs up. Until next time, stay warm, stay green, stay tuned. Goodbye.